Hey everybody, it's Dr. P again. These are the frequently asked questions for this week's problem set. I picked out several. You'll notice that I'm not answering all of the questions this week, and I'm sorry about that. It'll never be possible for me to answer all of the questions that everybody asks, but there were several this week that were common that I wanted to go over. I wanted to start with one that came out of your work on problem number 1. That was, what conceptually do the dot and cross products mean? That's a great question. It's really hard to tell a clear story about what the dot product means. I know that some of you are working on trying to find a way to draw what the dot product is, and I thought that was great. Actually, it's pretty hard to do, though. It's pretty hard to draw a picture of what the dot product of two vectors is. But most of the geometric meaning that can be gotten out of the dot product is contained in this formula that you probably learned in class. This formula here, V dot W, equals the magnitude of V times the magnitude of W cosine theta, where theta is the angle between the two vectors. This contains most of what you need to know geometrically about the dot product. Now, I should say a little bit about this angle here, and I know that if I use different colors, they're probably not going to be visible, but I'm going to try blue. Blue tends to work. This angle you have to be a little bit careful about. Okay, I'm going to draw an example here. If I draw two vectors, V and W, actually, let's make that a little bit different. Okay, notice where the arrows are. If I want to talk about the angle between these two vectors and use this formula to find it, that is not going to give me this angle here. And the reason is I haven't actually drawn the angle between the directions of V and W. I put them tip to tail so that V is going this way and W is going this way. The angle that I get out of this formula is going to be the one I'm going to draw now. So I'm trying to draw the same vector. I probably got it a little bit wrong, but I want this vector and this angle here. That's the angle between the directions of V and W. You notice that V is going this way and W is going this way, and the angle between those is an acute angle. The angle that I've drawn previously was an obtuse angle. That is not the angle that you get out of this formula. Okay, so to say a little bit more about what this does tell you, one thing that you can very quickly read from this formula, suppose that I give you two vectors in component form. So V equals 2i plus 3j plus k, and W is, let's say, 3i minus 4j plus k. The dot product of those is going to be V dot W equals 2 times 3 minus 3 times 4 plus 1 times 1. And that comes out to 6 minus 12 plus 1 is negative 5. It's hard to tell you a very clear picture of what the negative 5 is geometrically, but the fact that it's negative tells you something important about the two vectors. It tells you that if you put them tail to tail, V and W, they will be at an obtuse angle to each other. Now, why is that? If I look at this formula here and put in what I know that the dot product is negative 5. I don't know exactly what the magnitudes of V and W are. I could find out pretty easily, but I don't have to find them to know that this is going to be a positive number and this is going to be a positive number, which means that at this point I know that this is negative, these are both positive, they're being multiplied by the cosine of theta. That means cosine theta has to be a negative number. What it is exactly I'll leave for you to figure out, but the fact that cosine theta is negative tells me that it's an obtuse angle. Okay. Again, that's assuming that V and W are put tail to tail, so I'm looking at the angle between the directions of those vectors. Okay, now what does the cross product mean? Let's suppose that I draw two vectors V and W. These are roughly the same as before. And let's suppose that I took their cross product. What that's going to do is it's going to give me a vector that is perpendicular to both of these. Now I've drawn both of these in the plane of the whiteboard, which means that their cross product is either going to go out of the whiteboard or into the whiteboard. The magnitude of that vector, the magnitude of v cross w, is going to be the area of the parallelogram spanned by v and w. And that looks like this. So the area of that parallelogram, that's going to be the magnitude of the cross product, which again is a vector. Okay? The fact that the magnitude of a vector is equal to the area of a parallelogram is kind of a weird deal, and it takes some work to explain why that's the case, but you can find that in your book if you'd like to know more about why that is. Now, what about the direction of the cross product? This is important. In this case, I have v pointing this way and w pointing that way. So if I want to know the direction of v cross w, I'm going to use the right-hand rule. The way that I do that personally is I take my hand and I start by putting my fingers, my four fingers, in the direction of v, and then trying to bend them in the direction of w. If I'm able to do that, then the direction that my thumb is pointing, in this case into the board, tells me the direction of v cross w. Okay, but what if I changed the order of these two vectors? What if I crossed w with v, took w cross v? Would that be the same thing? Well, if I look at the direction of w cross v using the right-hand rule, I'm going to take my hand, put it in the direction of w, like this, and then try to bend my fingers in the direction of v. My thumb is going to point out that way, out of the board this time. So it turns out that v cross w and w cross v point in opposite directions, and as a matter of fact, they are the very opposites of each other. That is, w cross v is equal to negative v cross w. And since YouTube puts a limit of 15 minutes on these videos, I'm just going to cut them off after each question. So that's the end of the first video, but I'll be back with another one in just a minute.